This video will explain how to use the z-table to solve between problems. Okay, we're going to carry on with this worksheet. In the last video we did to the right and to the left videos, plus we learned how to use the basic z-table. Okay, so now we're going to work on how to do between problems. So let's just get started. Okay, number 9 asks us to find the area between z equals 1.23 and, whoops, I'm too eager to get started. Here we go. It asks us to find the area between z equals 1.23 and z equals 1.9. So I'll draw my curve. Okay, so here's my mean. So it's asking us to find the area between, here's my first z value, 1.23, and then I'll make my second one. I'm spreading them out more than they really would be so that we have room to see what's going on. Okay, and the problem is asking us to find the area between those two values. Okay, if you remember how to use the table, which you should, you know that if we look up these values in our z-table, we can get their p-values, okay? And the p-value of 1.9, the p-value of 1.9 is going to include all of this, isn't it? Okay, I'll just shade that in widely spaced blue, okay? So that will be the p-value for z equals 1.9, okay? So that's too much for the problem. If we use that p-value, it's going to be too big, isn't it? Because we just want this black shaded area. Now if we find the p-value for our other z value, 1.23, we'll do that in red. Okay, that is going to be, I guess I'll do like a diagonal shading. That's going to be this. Okay, so the red is the p-value for z equals 1.23. Okay, so again, if you understand the characteristics of the curve, you can see that we can take all of this blue, okay, and if we subtract the red, we're going to be left with the black, which is what we want, okay? So let's go ahead and look up our p-values and then we can solve the problem. So first thing, we want the p-value for z equals 1.9. So let's look on our table. So z equals 1.9. Oops, I don't want all of that. Okay, z equals 1.9 has a p-value of 0.4713. So we'll write that here. 0.4713 is the p-value for z equals 1.9. Let's look up the p-value for z equals 1.23. Okay, so 1.20123. Here is the p-value for z equals 1.23. 0.3907. 0.3907. Okay, now I've tried to show graphically how we're going to solve this problem. If that didn't make sense to you, what you can remember is that if the z values have the same sign, okay, in this problem, problem number 9, they're both positive, aren't they? The way we'll solve that is we're going to look up their p-values and then we're going to take the big p-value and we're going to subtract the small p-value. Okay, so we did that. We looked up the p-values for the two z-values. This one is bigger, yeah. 0.4713 is bigger than 0.3907. So all we have to do to find the area between those two values is just subtract those. Okay, and if we do that, we're going to get 0.0806. Okay, so this is the rule for solving a between problem when you have z-values with the same sign. So we would use the same process for this, okay? These are both negative, aren't they? So we would use this same rule, okay? Big P minus small p, okay? Because they're both negative. And I'll jot that down here. Okay, I don't want to actually do that problem. I'm just going to write it down. Big P value minus small p value. Okay? So we've learned the rule for how to do a between problem if our z values have the same signs. So now the final problem we want to do, well, maybe you don't want to do it, but you have to, is to find the area between z values with different signs. Okay, draw my curve. So here, question 13, they say find the area between z equals negative 1.63, negative 1.63, and z equals positive 1.24. Okay, 1.24. And here, of course, is my mean. Okay, so if we look up 1.24 in the table, we're going to find its p-value, and its p-value represents the area that I'm shading in pink. Okay, that will be I think this is too big to write with. That will be, make it thinner, that will be the p-value for 1.24. Okay, let's look on our table and find it. Okay, 1.24. 1.24 has a p-value of 0.3925. 3925. Okay, now we're also going to find the p-value for our other z value, which is negative 1.63. So let's look on our table. So 1.60123. 1.63 has a p-value of 0.4484. 0.4484. Okay? So that represents this that I'm shading. .4484. This is the p-value for negative 1.63. Okay, so if we want to find the area between these two z values, okay, the area between, I'll shade it with widely spaced black lines. You know, this is the area between, isn't it? And I think it's pretty logical. Okay, let's write the rule. So doing a between problem, with z values with different signs. what I mean by that is one positive, one negative. Okay, all we have to do is add their p-values. Okay, so I'll write that here. We add their p-values. Okay, so this problem, the answer is going to be 0.4484 plus 0.3925. Okay, and that is going to give us an answer of 0.8409. 0.8409. Okay, so I've shown you how to do between problems, and as you've seen, there's one rule that you follow if you're doing a between problem and you have same signed z values. You have two positive z values or two negative z values. And then there's a different rule to follow if you're doing a between problem with differently signed z values, meaning one negative z value, one positive z value.